Very good afternoon to one and all. Today we are going to see about the power flow equation or load flow equation. Power flow or load flow model in complex form is obtained by writing a complex power matching equation at the each bus. Say, for example, this is the generator bus, this is the load bus. So in the generator bus, what is the apparent power here? Apparent power is nothing but real power plus reactive power. PJI plus Q into GI. That is the power PGI plus J into QGI. That is the power generation at real and reactive power. Okay, power generated by the real and reactive power. That is nothing but PGI plus J into QGI. So in this load bus or demand bus, we call what is the reactive power here? That is nothing but PDI plus J into QDI. That is nothing but power at the demand bus, that is PDI, and real power at the demand bus and the reactive power at the demand bus or load bus, PDI plus J into QDI. Okay, so what is the voltage at that bus in the load bus? VI, and the current at the load bus is II. So the net power injected at the injected into the bus I. So the net power injected into the bus I. So what is the apparent power? Apparent power is nothing but SI is equal to SJ minus SDI. SGI minus SDI. That is the apparent power at the generator sector and also the apparent power at the demand sector. That is SGI minus SDI. Okay, because generation minus demand. That is from the power balance equation. Power balance equation nothing but generation minus the demand. Okay, so the net power, that is okay, loss is equal to generation minus the demand. Okay, so here SDI is nothing but apparent power generation. SDI is equal to apparent power of the demand side. So where PI is equal to PG minus PD. What is PG? PI is the power injected at the ith bus, and PG is nothing but power generation at the generation bus, and PD is nothing but power power consumed at the demand bus. So PI is equal to PG minus PD. So here in the apparent power, SI is equal to SGI minus SDI. SGI is nothing but PGI plus J into QGI minus PDI minus J into QDI. So here, so SDI is nothing but the combination of real power and reactive power, and SDI is also combination of the real power and reactive power. So here the generator bus, the apparent power is nothing but PGI plus J into QGI minus PDI plus J into QDI. Simplifying, you take this alone and this alone. So here PGI minus PDI plus J into QGI minus QDI. So this we have taken as commonly as PI, and this we commonly taken as QI. Okay, so PI is equal to PGI minus PDI, and where QI is equal to QGI minus QDI. So where the net apparent power SI is equal to PI plus J into QI. Okay, so this you need to remember. SI is equal to PI plus J into QI. Next, we know that P plus J into QI is equal to VI into II star. So IA star is nothing but phase angle. IA is equal to that phase angle will be in the negative. That is delta I will be in the negative. So take this as equation number 1. Why it is negative? Because if you see all the loads, many of the loads are the inductive loads. All the loads, majority of the loads are inductive loads. So few only capacitive load and few only resistive load. So for inductive loads, the phase angle will be negative. Okay, so the delta I will be negative. So we are taking here as Bi into Ii star. Consider two bus system as shown in the figure below. So two bus system, there are two buses are there, two generator bus. So the voltage at the bus number 1 is V1 and the voltage at the bus number 2 is V2. Next, the impedance at the offline charging, admittance is Y10 here at the bus number 1. Offline charging admittance at the bus number 2 is Y20. That is at bus number 2. And the impedance between the bus number 1 and 2 is Z12. That is nothing but Y12 is equal to 1 divided by Z12. That is impedance Y12 is equal to admittance Y12 is equal to 1 divided by impedance Z12. So let I1 be the net current or bus current entering into the bus 1. Okay. Next, I2 be the net or bus current entering into the bus number 2. So this already we framed from the equation. So the current matrix is equal to Y into Y matrix into B matrix. This already we have seen from the basic equation. If you have doubt in this, you go back to my previous class and you see this, the current I is equal to Y into B. So here in the matrix form, there are two currents available here because two buses. So two currents available here. So I1 and I2. That is nothing but Y11 into Y12 into Y22. This is the Y matrix here. Why it is 2 cross 2 matrix now? Only two buses are there. So that's why here 2 cross 2 matrix. If three buses are there, 3 cross 3 matrix will come. One bus is there, means 1 cross 1 matrix will come. Depend on the bus size. Next, what is this V here? So V matrix is V1 into V2 because two buses, two voltages are there, V1 and V2. Now, what about this Y11? So Y11 is nothing but Y10 plus here Y12. Okay. Next, Y22. Y22 is nothing but here at the bus number 2. Here Y22 is nothing but Y20 plus Y21. Okay. Next, Y12 or nothing. Y12 is equal to Y21 is equal to minus of Y12 or Y21. Okay, so minus of Y21. So in general, we'll write this Yij is equal to Yij into, that is phase angle of theta Ij. In general, we can write like this. So what is this theta Ij? You know, cos Ij plus sin Ij. Just substitute here and elaborate this equation. That is Yij modulus of Yij into cos theta Ij plus j into Yij modulus into sine of theta Ij. Take this as equation number 2. By solving the above matrix, that is just we have to multiply this 2 cross 2 matrix with this V1 and V2, that is rows into columns. Okay, so if you multiply this Y11 into V1 plus Y12 into V2, like that it will come. So I1 is equal to Y11 into V1 plus Y12 into V2. Similarly, I2 is equal to, so from this matrix, I2 is equal to Y21 into V1 plus Y22 into V2. The same thing, Y12 into V1 plus Y22 into V2. In general, the net current entering into the ith bus, net current. So this is the current. So these two equations are similar. So what we are doing is we are just rewriting this above. Okay, so above equation in the rewriting this above equation in this generalized equation. That is n. Okay, so I. So II is equal to yi1 v1 plus yi2 v2 plus up to yin into vn. In the generalized format, we are writing like this. So in generalized format, this we can rewrite as summation j is equal to 1 to n yij into vj. Okay, so IA is equal to summation J is equal to 1 to N Y ij into Bj. This we are taking it as equation number 3. Now, SI is equal to Pi minus J into Qi. Okay, from the equation 1, SI is equal to Pi minus J into Qi. That is nothing but Vi into II star. Okay, so Vi into II star, or otherwise Vi. So here we have taken as Vi star into I. So anything is, so for pure inductive load, load reactive power is taken as negative. So here we are taking as Vi star into I. So SI is equal to Vi star into I. That is nothing but Pi minus J into Qi. So why this minus J into Qa already I have explained from the previous. Because of that pure inductive load, this reactive power is taken as the negative, or a pure inductive load is associated with the negative reactive power. Here, substitute IA in the from the equation 3 in this equation. Okay, so IA we already from the equation 3. You just substitute equation 3 in the above equation. So you'll get a Pi minus J into Qi is equal to Vi star into summation J is equal to 1 to N Yij into Vj. Why? How this comes now? IA is equal to summation J is equal to 1 to N Yij into Vj from equation 3. Just we are substituting equation 3 here. So this equation is rewritten as like this. Vi star into summation J is equal to 1 to N Yij into Vj, where I is equal to 1 up to N. There are N complex variable equation from which N unknown complex variables are there. That is V1, V2 up to V1 can be determined. There are N complex variable equation from which N complex unknown variables like V1, V2 up to Vn can be determined. So substitute equation number 2, that is Yij in the above equation. So Yij from the above equation, equation number 2, Yij is equal to Yij into angle of theta ij. Okay, so that is nothing but cos ij plus sin ij. Okay, so if you substitute for theta ij, cos ij and sin ij will be substituted over here, because simply like phase angle is given. So cos ij plus sin ij for real power cos ij reactive. Like that, we are substituting here. So here we are substituting Yij from the equation number 2. We are substituting in place of Yij. We are taking and substituting from the equation number 2. So this above equation is rewritten as Pi minus J into Qi is equal to Vi star into summation J is equal to 1 to J is equal to 1 to N Yij into delta ij into Vj. Instead of Yij, we are substituting Yij into angle of theta ij into Vj. Where Vi is equal to Vi into theta I, Vi star is equal to Vi into minus of theta I. Next, Vj is equal to Vj into theta j. Next, del I is nothing but phase angle of the voltage. Phase angle of the voltage. Next, Pi. So here we are substituting Vi star and Vj in the above equation. So here we can get a Pi minus J into Qi is equal to summation J is equal to 1 to N Vi modulus into Yij into Vj modulus into delta Ij plus okay delta J minus delta I, because Vi star is nothing but Vi into minus delta I, and here Vj is nothing but Vj into delta J. So this phase angles we are adding theta Ij plus delta J minus delta I. So here equating real and reactive powers, we obtain the equation like this. So Pi is nothing but summation j is equal to 1 to n bi modulus into yij modulus bj modulus cos into cos theta ij plus theta j minus theta I. Next, reactive power qi is nothing but minus of summation j is equal to 1 to n bi into yij modulus into Vj modulus into sine of theta ij plus delta j minus delta I. So this is the real and reactive powers. By equating this, and we can rewrite this above equation as like this also. Pi is equal to Vi squared into Yii into cos theta ii. This real power alone we are taking it as cos theta ii plus summation j is equal to 1 to n Vi into Yij Vj cos theta ij plus delta j minus delta I. Take this as equation number 4. Similarly, the reactive power QA is equal to minus VI modulus of VI square into modulus of YII into sine theta II minus summation J is equal to 1 to N VI into YIJ into VJ sine of theta IJ plus delta J minus delta I. Take this as equation number 5. The PI and QI equation are called polar form of power flow equation. PI and QI are called this PI and QI are called the polar form of the power flow equation or nothing but static load flow equations. Okay. So for n bus system, there will be 2n power flow equation. Each bus is characterized by the 4 variables, that is PI, QI, VI, and delta I, resulting in a total 4n variables. The power flow equations can be solved for 2n variables if remaining 2n variables are specified. Okay, so for an n bus system, there will be 2n power flow equation. Each power bus is characterized by 4 variables, that is Pi, Qi, Vi, and delta I, from the resulting in the total 4n variables. Next, the power flow equation can be solved for 2n variables if the remaining 2n variables are specified. This is of the power. This is nothing but the power flow equation or static power flow equation. So if you understand this, you can easily solve your Gauss-Seidel method and Newton-Raphson method or Fast-Egal method, because there we are using this PI, QA and all. So you know where this PI and where this QA comes from this power flow equation or static load flow equation. So you can easily understand while knowing the Gauss-Seidel algorithm and as well as Newton-Raphson algorithm or fast-decoupled algorithm. Okay, so in GS algorithm and in our algorithm, we are using this equations directly, PI and QA directly. There you should not have the doubt how this equation comes. This equation comes from this power flow equation that you need to